Good day, students, and welcome to another edition of Learning Math. Today we're going to start talking about the math of chance or the math of probability. So this is all about measuring what are the odds or what are the chances of something happening. So there are some key vocabulary words that we're going to go over first. Then we're going to look at the definition of what probability actually means, and then we're going to go over how we calculate it. So you should receive this graphic organizer from your teacher. If you don't, you can kind of fill in the definitions and the examples as we go. I'll let you format it in your notebook however you think is best. But this graphic organizer is going to really help us have everything laid out in a nice organized way. So the first thing I want you to do is I want you to write down the 3 definitions to these words here in blue. Go ahead and pause the video and copy down these definitions. Okay, so now that we have the definitions copied down, we're going to go over them and go over some examples. So when we are looking at the odds or the chances of something happening, we call the problem that we're looking at an experiment. So just like how in science you have experiments where you're testing a hypothesis to see if something is true, when we are trying to figure out what are the chances of something happening in math, it is also the form of an experiment. We're trying to see what are the chances that, a blue marble gets picked from the bag, or the card we pick from the deck is a red card, or the song we pick off of an album is our favorite song. Like, it just depends on kind of whatever the situation is. So an experiment is an investigation with varying results. So let's just use like a very simple experiment to kind of go over the other definitions. So let's say we flip a coin. Okay, that is an investigation with varying results. When we flip a coin, it can either land on heads or it can land on tails, right? Or depending on the coin, right? It may not be heads and tails, or maybe other stuff on the coin, but it could be one of those 2 things, right? So when we decide, what are we looking for? Like, what is the chance of the coin landing on heads? If we are looking at that particular thing, such as heads, that's a possible result from the experiment, or what's known as an outcome. So when we want to think about, what are the odds of something happening? Let's say, what are the odds that the coin lands on heads? Okay, that's what's known as an outcome. When we list out all of the outcomes that could happen from an experiment, that's what's called the sample space. So in this experiment, all of the outcomes are going to be either heads or tails. There's only 2 outcomes in this whole experiment, which is known as the sample space. If we had an experiment such as like a deck of cards, right? If we wanted to know the set of all possible outcomes, we would have to list out like every single card in the deck. So like a 2 of clubs, a 2 of spades, a 2 of hearts, and so forth. Okay, so depending on the experiment, you could have a really big sample space or you could have a really small sample space. Let's look at some other examples. Let's say we're looking at a state that begins with the letter O. So if we want to have the set of all possible outcomes in this experiment, we need to name all of the states in the United States that start with the letter O. So we have Ohio, Oregon, and what's the other one? Oklahoma. So we have 3 possible outcomes, and this is our sample space. This is the set of outcomes. These are all the states in the United States that start with the letter O. Okay. Let's say we have another situation. We're trying to choose a random day of the week. So a day of the week is chosen. Well, let's figure out our sample space. That's all the days of the week. So we have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. I just abbreviated for the sake of time. And how many outcomes are there altogether? There's 7, because there's 7 days of the week. So when we are looking at the probability or the chances of something happening, we need to know what is the outcome that we are wanting, and then how many outcomes are there total, as well as what are all of the possible outcomes. And in another video, I'm going to show you how we can make what's called a tree diagram, a visual diagram, to kind of map out what all the possible outcomes would be, so we can visually see everything that's happening in an experiment. So let's actually talk about this definition of probability now. So now that we know kind of some key pieces involved, probability is a measure of chance of a specific event or an experiment, you could fill in experiment, occurring. So when we are measuring the odds of something happening or the chance, that's what's known as probability. And the way that we notate it is this capital P, and then inside parentheses, it has E, which means event. So if I want to say, what's the probability of getting heads? when we flip a coin, you might see the problem written as P parentheses heads on the inside of it. Okay. So you'll see that in some examples that we're about to do. So the way that we can express probabilities are we can express them as a ratio of what's known as favorable outcomes. So what we want to happen, like we want the coin to land on heads, or we want to choose Monday in our set of days of the week. So it's expressed as a ratio of favorable outcomes to the total number of outcomes. So what we want out of the total number of outcomes, or that sample space that's up there. The ratio can be written as either a fraction, decimal, or a percent. For the most part, you're going to be seeing it written as either a fraction or percent, but you can write it in any format. If it's not given to you, like if it doesn't say write it as a fraction, decimal, or percent, a good rule of thumb is just to always assume that you write it in a fraction. The sum of all the probabilities in a sample space should equal 1. So what that means is like, okay, if we're looking at our coin example, the odds of a coin landing on heads is 1 out of 2. Right? There's one outcome out of 2 possible outcomes where the result is heads, or a 50% chance. That means with tails, it's the same thing. There's a 1 out of 2 chance when we flip a coin that it's going to land on tails. So 1 out of 2, or 1/2 plus 1/2 is going to equal 1 whole, or 50% plus 50% equals 100%. So if it says like, what's the probability of something not happening, which we'll kind of see an example of that, you can kind of use that information. Like, well, I know the total is supposed to equal 1, so I can take what I have and subtract it. So we'll look at some examples like that in a moment. But let's look at an example with a spinner. So spinners show up a lot in probability questions because there's many different outcomes that could happen. So it says the spinner below is used in a game. If spun once, find each probability. So you'll see how it's written over here. This is saying what's the probability of the coin, or not the coin, excuse me, the spinner landing on the number 9. What's the probability of it landing on at least a 12? What's the probability that it lands on a perfect square? What's the probability that it's not shaded, and so forth? Okay, so we're just going to do a couple of these for the sake of time. So I'm going to do letter A, letter B, and let's do letter D. Okay. I will have the other ones listed in the table of contents for like answers, or you could always check with your teacher if you want to try the other ones on your own. So let's look at what's the probability that if we spin the spinner, it lands on the number 9. Well, we only have one number 9 on this whole spinner, and there are 16 spots on this spinner, or the sample space is 16. So we have a 1 out of 16 chance that the coin, or I'm sorry, I keep saying coin, that the spinner lands on the number 9. If we say, what's the probability that it lands on at least a 12? So that means 12 or above. So if I count how many numbers are 12 or above, we have 12, 13, 14, 15, 16, and that's 5 numbers out of the 16 spaces. So there is a 5 out of 16 chance that if you spin the spinner, it lands on a number greater than 12, or at least 12. So you'll notice the probability of this happening is higher than the probability of this happening. So if, like, let's say you're doing something that you probably shouldn't be doing at your age, gambling. Okay. If you were to like bet money, which like, don't ever do this. Okay. Like, save your money, be smart. But just for the sake, let's bet candy. How about that? If you had candy. Okay. If you're trying to win candy, and they gave you these 2 options, right? You would probably pick this option because the odds of this happening is much higher than the odds of this happening. So you're more likely to win candy if you're betting this. Okay. Let's look at another example. Let's do letter D. So it says the probability of the spinner landing on a section that is not shaded. So if we count the ones that are not shaded, 1, 2, 3, 4, 5, 6, 7, there's 7 out of 16 that are not shaded. So there's a 7 out of 16 chance that you land on one that is not shaded. I didn't have to simplify any of these fractions, but for example, like if I did the probability of landing on a 2 or an 11, I'll just circle this one and do it as well. So there's 1, 2, and 1, 11. So that's 2 out of 16 that I could land on, either the 2 or the 11. So there's a 1/8 chance that that's going to happen if I simplify the fraction. So if you can simplify your fraction, make sure you do it. It says up here to put it as a fraction, decimal, and percent, but I was just going to do fraction for the sake of time. Okay, let's talk about one more situation, and then I'm going to kind of let you get involved with your practice question. So we're going to take this paper, flip it over to the back, and we are actually going to look at the very bottom where it talks about the complements of an event. Okay, the complements of an event. So the complement of an event is the probability of an event not occurring. Okay, so since the sum of all of the probabilities is equal to one whole, the way that we can find the probability of something not happening is if we take the number 1 and subtract the probability of that thing occurring. So what I mean by that is, let's look at an example so it makes a little bit more sense. So it says the probability that it will rain tomorrow is 3 out of 8. What is the probability that it will not rain? So if I know that there's a 3 out of 8 chance that it is going to rain, in order to figure out what the probability is that it's not going to rain, what I'm going to do is I'm going to take the number 1 and I'm going to subtract that probability of it actually raining. Okay, so 1 minus 3/8. Well, one whole, if we put it as 8, is going to be 8 out of 8. So 8 out of 8 minus 3/8 means that there is a 5 out of 8 chance, or 5/8 chance, that it will not rain tomorrow. So the odds of it not raining are actually higher than the odds of it actually raining. So the probability of it not raining was when we just subtracted the probability of it actually raining from the number 1 whole. Okay, let's do another example. Let's look at number 9. It says, if the probability that someone will win a game at the carnival is 1 out of 24, what is the probability that they will not win? So if the probability that they win is 1 out of 24, the probability that they will not win is 1 minus 1 out of 24. And if I rewrite this as 24/24 to be equivalent to 1 whole, that means that there is a 23 out of 24 chance that they will not win. So there's a very strong chance that you are not going to win a game at a carnival based on these odds. There's a very small chance you can, but most likely you're not going to win based on the odds. Okay. I'm going to let number 10 and number 11 kind of remain just other practice questions for you if you want, for the sake of time, because you guys can kind of see how to solve for the complement. Your practice questions for this video are actually going to be questions 5, 6, and 7 up here, on the back of your graphic organizer. So make sure you, I would suggest writing out the sample space if you have the chance. If you are not 100% sure a particular part of the question, especially when it comes to the deck of cards, please ask your teacher to kind of show you or explain to you all the cards in a deck of cards. You can also just like Google that information too, just like what is a deck of cards composed of, and it'll tell you how many colors, how many suits, how many numbers, how many kings, queens, jacks. Like, it can kind of break down all that information for you. So you can check your answers to these questions in the table of contents. Again, if you have any questions, this might be a good video to watch again twice, or to kind of check in with your teacher to make sure you understand some of the vocabulary. But essentially what we're doing is we're looking at the odds of something happening, looking at what is going to happen out of the total number, and kind of just writing that as either a fraction, decimal, or percent based on how the question wants us to. Most of the time it's going to be a fraction. As always, if you have any questions, please feel free to reach out, and have a great day, and see you in the next one. Bye.